Okay, so welcome. This is as we have been discussing in the class regarding water quality, water treatment. So today we have brought you to a water treatment plant on the campus of IIT Kharagpur, and with me is Mr. B.B. Rai. He is Senior Executive Engineer in Waterworks at IIT Kharagpur, and he is the overall in charge of this plant. So he will give a brief overview how the plant works, and then we'll have a walkthrough to the plant. So,
okay. Well, we have one of the source for water that is 40 kilometer away from this place, that is Kansauti river. We get the water from the river. It goes to our cascade aerator. There is a aerator. It mixes with the air, and this again it goes to the flash mixer and goes to our clarificator. In a clarificator we have a very good system for rotating everything, and solid particle gets settled down. There we mix the chemical dosing plant. From chemical dosing plant we use the chemicals to purify the water what we get from the river source. From there we have three beds, multi-layer of beds. There water goes, and there it's filter from filter. We get the clear water in the water reservoir. From water reservoir we supply to the campus people, and again we generally do the back flushing of the water, and back flushing of the water also recycle to our recycle bed, which is outside this room. And from recycle again the water recycle to the cascade, and again it follow the same process for purification. Thank you.
Hello everyone. So we are here at the bottom of the cascade aeration tank. This is where the water treatment unit starts. Water from Kasai river, also known as Kansawati river, enters through this conduct at the aeration tank. From here the water moves upward to the cascade tank. So we are here at the very first point of our treatment unit. From here we will go to the top of the cascade unit, and from there we will elaborate further about the subsequent treatment plant. So as I said that at the bottom of the cascade unit the water enters. From there it enters to the top cascade unit where the aeration of water will take place. So we are moving towards the top of the cascade unit, how it works and what is the function of the cascade unit, why we do the cascade aeration, detail of which will be told by Sagarika Panigrahan, who is another teaching assistant. From there we will move towards the subsequent treatment unit, and she will explain each unit independently, its functions, why we do that, what is the importance of that.
Hello everyone, now we are at the aeration treatment unit. Aeration is a process sometimes used in preparing potable water. It may be used to remove undesirable gases dissolved in water, or to add oxygen to water to convert undesirable substances to more manageable form, that is oxidation form. Aeration is a more often used to treat groundwater, as most of the surface water have been in contact with atmosphere for a sufficient period of time for gas transfer to occur naturally. Aeration mainly used to remove carbon dioxide and hydrogen sulfide present in water. In addition to carbon dioxide and hydrogen sulfide, aeration also helps in improving removing Fe2 plus and Mn2 plus present in water. Actually what happens when we add oxygen to water, that Fe2 plus combines with oxygen and get converted into Fe3 plus, and Mn2 plus combines with oxygen and get converted to Mn4 plus. And Fe3 plus and Mn4 plus are insoluble in water. So when we provide sedimentation in further treatment unit, this gets settled down at the bottom of the tank.
Now we are at the coagulation tank. Coagulation tank is mainly comprised of flash mixture, then clarificator. You can see this coagulation tank. In coagulation tank, what we do rapid mixing of the coagulant, that is alum. We add alum here, then we provide a rapid mixing so that alum gets completely mixed with the water.
Now we are at the top of clarifloculation chamber. As you can see, there are two concentric chambers are here. The inner chamber is for flocculation and the outer chamber is for clarification. The water from flash mixture enters into the flocculation chamber. In flocculation chamber we provide a slow mixing. The purpose of slow mixing is to provide the formation of flux. The outer chamber is mainly for clarification. In clarification what happens, type 2 settling occurs. As we discussed in our lecture, there are 4 types of settling, the type 1, type 2, type 3 and type 4. In plain sedimentation type 1 settling occurs, and in clarifloculation type 2 settling happens. So in type 1 settling, this settlement of discrete particle in dilute suspension happens, whereas in clariflocculator type 2 settling happens, where sedimentation of flocculent particle in dilute suspension occurs. What is the difference between discrete particle and flocculent particle? Discrete particles are those which don't change their character, that is size and velocity with respect to time, whereas flocculent particles are those which change their character with respect to time and space. In flocculation chamber, what happens? The particles velocity varies from depth to depth, so the velocity increases with depth. Water from clariflocculator enters into the rapid sand filter. As you can see, in the water is entering into the rapid sand filter, and there is a central pipe. Then from the central pipe, water enter into the lateral pipe. The purpose of lateral pipe is to distribute the water through all sand beds uniformly. The cleaning of rapid sand filter occurs twice in a day. 2 to 6% of the filter water generally used for the backwashing purpose. As you can see in this rapid sand filter, that backwashing is going on. The compressed water is allowed to pass through the sand bed, which creates bubble on the top of the bed.
So water, after getting filtered using the rapid sand filter, enters into the two diversion. Once the clear water enters into the sump well, where water is disinfected using the chlorination, and the discarded water, that is using a backwashing, enters into the sedimentation tank. In the sedimentation tank, the water gets sedimented and the clarified water is recycled back to the starting of the treatment unit, where the fast mixing along with the coagulation takes place. From here, the sludge is pumped back to the sludge drying bed at the other junction of the treatment unit, where dewatered water is again recycled back to the starting point of the treatment plant, and the sludge is discarded for further uses.
Now we are at the disinfection unit of water treatment plant. The purpose of the disinfection is to kill the pathogens present in water and to protect the water for further organic contamination. As you can see here, we are adding chlorine as disinfectant in water. The chlorine helps in killing the pathogens present in water. After chlorination, the water enters into the underground storage reservoir.
After the backwash water enters into the sedimentation tank, the clear water is recycled back to the starting point of the water treatment plant, and the sludge that is sedimented is pumped to the sedimentation, or the what we call as the sludge drying bed, where the sludge enters into the sludge drying bed one by one. The sludge drying beds consist of a filter media using a sand. The slurry sludge enters to the drying bed from the top, and water gets filtered. In the top layer, the sludge cake gets formed, and the sludge that is dried, that is cake, that is clipped up from the sludge drying bed and stored for the further disposal or further uses. The water that is filtered through this sludge drying filter bed is pumped back again to the starting point of the water treatment plant. So in this case, you can see the entire water, that is from backwash to the filter, every water is recycled back to the treatment plant, so resulting in zero loss of water from entire treatment plant.
Okay, now we are at the top of underground storage reservoir. Water from here enters into the elevated tank. From there it gets distributed along the distribution system.